Hello, in front of you right now is my new YouTube banner. I try to make it look fancy. I hope it is fancy. Now let's take a look at it. On the right side, there's a parabolic graph here. Can you think of any types of math associated with this parabolic graph? I listed a few here on the left side. Let's take a look at it. Integral. So if I integrate this function, right, from let's say this point to this point, I will get the area under the curve above the x-axis, right? Now let's say this is the y-axis, this is the x-axis, and this is a function of y equals to f at x. Let's say this point here is a, this point here is b. So if I integrate from a to b of f at x dx, I will get the area of the blue shaded region here. Okay, now next, derivative. So if I take the derivative of this function, right, and then put in the x value at a given point, I can find the slope of the tangent line at that point, right? Okay, so let's look at this point here. Say this point here. So go down here, this point would be, let's say, is t, right? So if I take the derivative of the function f at x, I will get f prime at x, right? So if I put in this value here, this point here, x equal to t, right? So f prime at t will give me the slope of the tangent line at x equal to t, right? Okay. Next, function. Okay, the parabola itself is a function, right? So the highest degree of power in the function, the variable, right, it will be 2, right? Okay, now next, factoring. Of course, if we factor this function, right, this parabola, and set it equal to 0, we can find the x-intercept here. So based on this, right, the x-intercept would be a and b here, right? So looks like if I have x minus a times x minus b equal to 0, right? Then we have x minus a equal to 0 or n x minus b equal to 0. Then x is equal to a, x is equal to b. These are the x-intercepts here, right? Okay, let me write this. The x-intercepts. Okay, I know that from this graph here, a looks like it's just 0. That's okay. I'm just talking about the concept here, right? Of factoring. Okay, next, physics. Projectile motion. So a projectile motion can be modeled by the parabola function like this. Assuming that air resistance is negligible, then it will be a perfect parabolic shape. And of course, if you factor into the air resistance, right, then it will not be a perfect parabolic shape. Okay, now, next, trigonometry or physics. Okay, so here, let's say you toss an object, right, at an angle theta. So here, you toss an object at an initial velocity, right, at an angle theta. So this, you have to break it down into component. So here and here, right? So this is the y component, this is the x component. And how do you calculate this component here, the y component? That will be v times sine theta, right? And how about the x component? Will be v times cosine theta. How do you get this? It's trigonometry. Okay, so this is also physics, right? But you have to apply trigonometry in physics. Okay. If you can think of more related math or physics topics based on this, just solely this parabolic graph, feel free to leave a comment below. And lastly, please consider liking and subscribing to my channel. Thank you.